Ming Jin from the Singapore office of Sombo Angel Partners, and I'm here today to talk about one of our recent investment, NuSpace Private Limited. So NuSpace aims to design, build and deploy nano-satellites to provide global connectivity services for IoT applications. This solution is very useful for remote areas where there's limited to non-existent communication infrastructure. IoT is becoming more embedded in our day-to-day lives, and the number of IoT devices and applications is expected to increase over the next few years. However, for IoT devices to work, they require connectivity. If we look at connectivity, traditional communication networks cover only about 20% of the Earth, and satellite communication is the only mode that offers truly global coverage. So traditional satellite communication is expensive, as large satellites have long development time and high capital expenditures. Nano satellites can help to address some of these problems and bring down the cost of using satellite for connectivity purposes. We believe this will have a huge impact for the entire IoT industry. So we chose to invest in NuSpace as they have an experienced team that is supported by a group of highly qualified advisors. So the team has previously launched Galileo, a scientific research nano-satellite for NUS, and they also have the support of NUS, which is one of the leading universities in Asia.
1, 0, 1, 2 years, going to lift off normal. 7, 8.
So our greatest value add for NuSpace will come on the commercial side. So one of the first things we did with NuSpace was to set a business plan and key milestones towards their first launch, which is scheduled for March 2021. As part of the process, we worked with NuSpace to identify key critical milestones and also to work out a budget to ensure that they had sufficient cash resources to reach the first launch. IoT is also an area where Sombo has active interest in and has and will be investing actively in for the next few years. We intend to introduce NuSpace to our other startups who require satellite connectivity for their IoT applications. After the launch of their first satellite next year, we also intend to work with NuSpace to identify other sources of funding such as government grants and funding from later stage venture capital to support the development and launch of a nano-satellite constellation for satellite connectivity purposes. So now I'll pass you on to the founder of NuSpace, Zhen Ning, who will go through in greater details his startup and business.
16 December 2015, the National University of Singapore launched its first nanosatellite, Galileo. Within the first hour of the launch, we managed to establish contact with our satellite. Galileo told us that it was alive and healthy, and it went on to fulfill a very successful mission, generating lots of scientific data for research purposes. That is how NuSpace began. A good day to all of you. My name is Zhen Ning, CEO and co-founder of NuSpace, and at NuSpace, our goal is to provide IoT connectivity in areas that are underserved. We have a problem. In today's digital age, 85% of the world is still not connected. This is an image of the Earth taken at night, and where you can see bright spots, those are areas with electricity. And with electricity, you would have connectivity. IoT technology requires connectivity in order for it to work. And as you can see, a large amount of areas is actually not connected, and that includes areas covered by the ocean. And this is a big problem for IoT technology. The IoT industry is expected to boom. 70 million devices for the asset tracking industry and 85 million devices for the agriculture industry. These two industries have one thing in common. They require devices to be located in areas with limited to non-existent communication infrastructure. There are existing solutions in the market, but they are not ideal. Existing solutions use large satellites the size of school buses in order to relay IoT data. These satellites are very expensive to build and to deploy, and they are optimized for high data rate applications and not IoT. Because of that, it becomes very expensive to relay a single IoT data packet. On average, it costs about 60 cents to relay such IoT data packets. And this is definitely not scalable, especially if you're talking about large data sets or data analytics application. Our solution is to launch a constellation of nanosatellites. These nanosatellites are the size of shoe boxes and they are relatively cheaper to build and deploy. Most importantly, they are optimized for IoT applications. And as a result, we'll be able to offer IoT connectivity service at 1/10 of the market going rate. So that's our goal. How are we going to achieve it? We have to take gradual steps. The Glacier project allowed our team to develop our technological capabilities. Today, we are able to design and build our own subsystems such as the payload computer and the attitude determination and control system, ADCS for short. We are then able to integrate all of these subsystems into a platform which we call the nanosatellite. These nanosatellites can be tailored for various applications such as aviation and maritime monitoring, communication, and imaging. While trying to go to the market, we realized another problem. And that problem is that there's no commercial satellite integration service provider and no commercial payload ride-sharing service provider within this region. This is an overlook of the number of companies that are looking to provide their own applications and services from space. And there's an estimate of about 24,500 satellites forming about 80 constellations to be built and deployed. Through the interactions with these potential customers, we realized that most of them actually do not have capabilities in building their own satellites. And this is where we think that our capabilities of building satellites can come in to complement these potential customers. So our go-to-market strategy is to start off by providing satellite engineering services, taking up one-off satellite build projects, and to provide payload ride-sharing services. The nice thing about this is that while working on customer satellites, we'll be able to see whether is there any extra space in their satellite, and whenever there's extra space in there, we'll work with our customers for us to integrate our IoT payload inside their satellites. And the moment one of these satellites go out into space, we'll be able to provide basic connectivity services. Our initial connectivity service will be able to fulfill applications that are non-time critical, such as weather monitoring, water quality monitoring, and agriculture monitoring. With our satellites up there demonstrating our capabilities, that's also when our company's valuation would increase, and we will then go out to raise more money in order for us to expand this constellation. With 14 satellites, we'll be able to serve applications that are semi-time critical, such as cattle tracking and asset tracking. And with 35 satellites, we'll be able to serve applications that are time critical, such as forest fire monitoring and tsunami warning systems. Our competitors can be split into two main categories. The first being the conventional satellite industry players building large satellites and using them to relay IoT data packets. They are cost ineffective. The second group are nanosatellite industry players building nanosatellites for IoT applications. They are cost effective, but we think that we have an edge over them. The key differentiators between them and us is that, to the best of our knowledge, they do not have in-house satellite building capabilities. Having in-house satellite building capabilities allow us to quickly adapt our satellite designs in order to fulfill our ever-changing needs of the customers. This will allow us to also build and deploy satellites that are far more effective. The second key differentiator is that our IoT connectivity will be based on LoRaWAN communication protocol. LoRaWAN communication protocol is a very well-established protocol, and it has been deployed on many devices that are used by IoT application service providers. Adopting the same protocol will allow us to bring down the barrier of entry for our customers to adopt our communication infrastructure. A bit of ourselves, myself the CEO and co-founder, and Dr. Losha, who is a co-founder and also the project investigator for Glacier, NUS's first nanosatellite. Together with us, we have a strong pool of advisors. Mr. Clarence Tan, who is the founder of Origin, he advises us on business and investment strategy, and Mr. Jonathan Hung, who is the president of Singapore Space and Technology Association. He's providing us with industry networks and connections. The team designed Glacier with a 1-year mission lifespan, but to today, it is still operational. That's more than 3 years already. And because of Glacier, the team was awarded the ASEAN Outstanding Engineering Achievement Award. I would say that this is definitely a testament of our engineering capabilities. These are our stakeholders and partners, and we are very fortunate to have NUS, Origin, and BNext to invest in our company. We have other technology partners as well as industry support, and we are very, very grateful for them in supporting us. In our pipeline, we have 3 satellites to be built, Glacier 2 and Glacier 3, which are satellites that are owned by NUS. We are assisting them to build these satellites. And NUX-1, which is a 100% company-owned satellite. This satellite will be hosting a propulsion payload from our partners as well as having our IoT payload. NUX-1 will be a technology demonstrator for us, and all these 3 satellites will be launched in 2021. I'd like to end off with this. Communication technology has advanced throughout the century. Starting in 19th century, we have the telegraph machine and the telephones, which relied on physical wires to relay data. Then in the 20th century, there was the introduction of wireless RF, and that gave us our mobile phones. Today, we are in the 21st century. What's the next big leap in communication technology? I believe the answer lies in space. Thank you.